consider bioinformatics only or whole workflows? I think this is quite simple to answer, but feel free to comment that. We discussed this morning about the perimeter of the initiative is that metagenomic only, which is what we did today most of the time. Should we consider metaproteomics? Should we consider metabiomics? There was some remarks this morning. There is pros and cons. Pros that you are enlarging your knowledge, of course. But of course, you are increasing the complexity of the studies because metaproteomics, for instance, and metabiomics is hugely complex compared to microbiome itself. And also, there are some questions about the what I call application-driven tools, which is when you have your bioinformatics okay, this is not the end of the story. You have to correlate different data sets. You have, for instance, mixed with the data coming from clinical studies, data coming from the dietary data. So there is some data fusion here, elements or some machine learning elements that could be factor in. So to be discussed, is that part of a program related to microbiome? Do we go beyond bioinformatics? Question marks, and that's the end of the first part. So we have two options here. We start with questions, or we jump directly to the theme number 3, as you want.
So somebody in the public has a question? Yes, please.
Thank you very much. In fact, you are just raising a very good question. I'm the CEO of IBBL Biobank, and this question number 2, metagenomic only versus metaproteomics and metabolomics, it's very important because the way you validate your process from day 0, from the time where your individual or your patient is collecting his her own stool, then for us as biobankers, it's very important because you optimize either because you want in fine to do metagenomics. In that case, that process can be very robust. If not, now, if you want to play with metaproteomics, metabolomics, and metagenomics, then obviously you need to sacrifice at the moment the robustness. And for instance, you won't be able to use this certain kind of tube any longer. You will have to freeze in minus 196 your sample. Otherwise, I mean, the yield will not be that great. So how do you handle that? Because asking the question first is very important to validate upfront.
Can I return the question to the audience, because this one is quite tricky. What you are describing is the design of the trial, and you have to decide at the beginning of the trial if you include or not include some elements. Honestly speaking, I totally will application dependent for sure. But my concern is that if we set up a new program within IMI, it's nice to shoot for the moon. You can include everything, but the risk of that is that it could be too complex and too risky and too challenging. So it's more a debate than a question to the speaker. I think this has to be discussed here in this audience. Should we consider everything, or should we focus ourselves on well-defined domains that are more controlled today?
Okay, so there is another question by Mark.
So Alain, when you perform the survey of the literature and discuss with the other people from your group, so I was just wondering whether when performing longitudinal studies, you could actually eliminate most of this variability, and then in this case would get more convergent results in terms of the delta and the trends, either for instance, more richness or decreased richness. So in other words, would it be possible actually to tackle many of these problems by proposing exclusively longitudinal studies, or by targeting more generic marker of this dysbiosis? Or do you think that there are few aspects that would need to be addressed anyway because there is even too much intra-laboratory variability?
So, Dushko, feel free to jump in, because I'm a strong believer in longitudinal studies, like you, Mark, I think, because we all know that the microbiome is not that stable. So you eat something, some seafood yesterday, and it's competition. So I don't see any serious application in our domain, diagnostics, and in general for medicine, without any serious longitudinal studies. That's what, for me, that would be the priority number one. And then number two, depending on the application, we should or not include proteomics or metabolomics. But let's start with what we have today in hand, which is classical metagenomics, and try to make it work. That's it. We know the issues. Let's fix it and do something concrete with that. I would prefer not to be too ambitious in an IMI program and to focus on medical needs.
But you know there are two levels of variability.
Sure.
So you address mainly here the inter-laboratory variability,
Yeah.
not really the intra-lab variability. And this could make a great difference, because if you have limited intra-lab variability, then in this case, through longitudinal studies, you might get perhaps more convergent and more robust results.
Yeah, that's likely. Yeah.
Thank you. So any other question here? Yes, Dusko?
Yeah, so one is just rebounding on Alain's suggestion. I really do agree that longitudinal studies are needed, and would like to bring to everybody's attention the fact that microbiome, we see the differences, and we also see the part which is not different.
Yeah.
So it's even not glass half full, half empty. I have the impression that the glass may be 90% full, but we scientists love differences. So we always focus on differences and say, oh, it's great, I see the difference. But by and large, it's unpublished data, and I share it with you. Vegans, 10% of the microbiome may be affected. Vegans. Okay, so they eat really quite extremely different food from us. 10% is a lot, but it's not that much. Okay?
Yeah, I think that's a very good remark. I think if we are able within IMI to define what is the conserved microbiome in human, the core of that would be great to build something on that. But this is not well defined today. There is no clear definition of this core microbiome.
Yeah, so it's a little bit more sophisticated notion than what we all have in common. That's very simplistic, very little. But a more sophisticated way of looking at it would be expressed in a way: 50% of your microbiome, Alain, and mine is shared with 50% of the population.
Okay, I see.
Okay? So, yes, there's quite a bit of common, but there are very few genes that you'll find in everybody. Now, I'd like, since I'm having the microphone in my hands, I'd like to, perhaps reiterate the fact, if we were to work on this bioinformatics aspect, which is so important, then we could try to focus it also on better characterization of strains and species that live in our bodies, as a complement to what you will introduce in the next part of your team. But the two go really hand in hand. And I really do agree with your notion. Let's try to develop good tools and try to give them, to the community.
Yeah.
Which,
or to sell them.
Which, selling implies service, and that sort of thing. So it's a good approach. But that seems to me really quite a nice objective.
So that's a perfect transition to the next theme.
Yes, exactly. But before moving to the next theme, which will focus more on the strains and on the characterization of strains that you just mentioned, we have two questions. So the first one is, intestinal tract has several biotopes, and each of them has a different microbiome. Stool is common sample, but does it not represent all of them?
I agree. But I have no solution, so.
I think it's quite straightforward. And then related to this first, let's say, introduction more than a question, human body has several other biotopes with their microbiome that are also functionally important. They should be investigated simultaneously. And then...
Yes, I agree too. This is what we are doing at Biomayo, but many academics are doing the same. We are studying stool samples, blood samples, respiratory samples, oral samples. And the idea is to combine everything at the end of the day, maybe in a couple of years, but I agree that that would be probably enlightening for applications. But this is, again, adding complexity to the question. Plus, yeah? Adding?
Because you can analyze, for instance, some less diverse microbiome, and that could allow you to be a bit less ambitious in terms of standardization and definition of, or assessment actually of your...
Maybe less diverse,
robustness
but
of
you
your
have
pipeline.
other difficulties. Like for blood, you have a question of sensitivity, for instance. For respiratory samples, you have viruses and bacteria that are completely mixed. So that's not that simple. Oral, of course, yeah.
Okay, so I think we can move then to the next presentation, always given by
Clicking?
Alain. Yes, so if you can put the slide of theme 3, please. Yeah.
So this theme was about collections, starting with strain collections and reference method and standardization. So we started with strain collections, to your point, Dushko. So this is not a blank page. There are many collections in the world, of course. I put a few of them here. And now there are networks of academics or sometimes companies that are merging the collections and facilitating the access to the collections. For instance, there is CAVRI in Europe. You can recognize the names here, with, for instance, ZSMZ, who is very famous in microbiome studies. So total number of strains is 140,000 strains. It's quite substantial. Even bigger is ECHO, for instance, with 61 members. I think that CAVRI is a member of ECHO, so you can, there is some double counting here, but here the total number of strains is something like 350,000 strains. That's very massive. And you have also very well-known collections, international or national or private. ATCC is very, very well-known. In Japan, they have very good collections, and at Biomerrieux, we have 100,000 small animals in our freezers in France and in the US. So some comment about that. Every collection is very specific for historical reasons. Sometimes they are specialized. You have a collection for single species, for instance, in reference centers. You have different status, of course. It's clear that building and maintaining a collection is a multi-year effort, and it's very costly, I can tell you. The notion of having a totally free access to those collections is questionable, because those are proprietary, so there is some cost attached to that, and people will not give the strains for free, for sure. And importantly, I think a small fraction of the bacteria that we find in the microbiota is cultivable. So there is a big interest in trying to grow them. So there is an old and new science at the same time, which is culturomics, so trying to grow the bugs that we find in different in samples, but that are not usual. So this mix of culturomics and metagenomics is very interesting for any studies based on microbiome. And this is still a field which is, I think, not that well covered. We know a few labs that are working on that, but probably there is a lot of things to be done here. The next one is about, let's say, digital collections, so databases. Here it's not a black match at all. It's a zoo of different bases in the world. I put some of them. So Silva is well known in microbiome because this is part of many bioinformatics pipelines. Green Genes, NCBI, of course, very well known. I put EasyBioCloud, which is a Korean private company which is offering for free access to their database, plus some services. RDP is another, I think, American database. There are networks of databases, for instance, in Europe, we have this RNA central group, which is merging 42 databases. And we have also private examples, for instance, Anterome developed, of course, over the time, a database for genes and for and species. And at Biomerrieux, we have also a database and knowledge base about those bacteria. So some comments about that. They are very diverse in contents. The level of curation is a never-ending question, especially if you want to develop clinical applications. You will have to curate your data for sure. As mentioned this morning, the metadata, the description of the strains, how it was collected, in which clinical setting, condition, is very important, but unequally represented in the database. Today, the vast majority of the database are about microorganisms only. We start to see some collection related to flora, so to mixture of microorganisms, but it's not that developed today. If you are interested in specific species, most of the time you find some sequences. But if you want to deep dive in different strains, quite often there is no data in the databases, so you are locked. There is, of course, poor coverage of what we call the microbial dark matter, the pathogens or the bacteria that do not grow. So by definition, they are not sequenced, and by definition, they are not in the database, which is a problem. Another issue is that very often those databases are coupled and embedded in softwares, which is nice for the user because it's very easy to operate. But in terms of traceability and understanding of the process, that's quite complex. So there's a dark box or black box effect, which is to take into account. Those bases are upgraded very often, every week, every month. So very often we have scientists coming to us and saying, "Okay, I ran my samples 2 weeks ago, and now the results are different. Where does it come from?" Quite often it comes from some software upgrade or database upgrades. Multiple taxonomies. There are many ways to describe bugs in the world. To give you an example, at Microbiome we have a database of taxonomies with 1.2 million entries in the database to describe the different bugs because different people don't use the same names. And last but not least, those tools have different licensing regimes. Some of them are completely open, like for instance NCBI. Some of them are for a fee. Some of them are mixed configurations. So a few words about standardizations. This is not a blank page, of course, hopefully. There are different initiatives in the world to try to cover that field. So MBQC, for instance, or as mentioned by Dushko this morning, IHMS was proposing some standards to process the samples. Well, people are aware, they are working on that, but clearly today, if you want to have a clear standard, this is not existing. So we should work on that, for sure. So if we try to set up a program about those themes, having access to relevant collections, databases, and tools, I think is key for the development of any application. And if you think about IMI, we are targeting medical applications, so the standards should be quite high in terms of quality. And again, I mentioned this beyond metagenomics question, should we consider metaproteomics and metametabolomics? And what I call application-driven database, which is, for instance, data related to lifestyles, diets, resistome, virulome. There are many other sources of information that should be considered when you develop applications. And like it seems number 2, standardization again and again is a cornerstone of any development. This is equivalent to theme number 2. I will skip that. So the conclusion is two things. The conclusion of the two groups. First, the goal of this group would be to help people that are supposed to develop applications, for medical applications or nutrition applications, help them, and they shouldn't lose time in developing pipelines and importing data and changing the format, and they should use simple tools, turnkey solutions, and focus on their work, which is medical stuff. And 2, again, standardization is absolutely necessary for that. For the open questions, so we have some debates about the necessity to create new databases, new collections. Do we want to create that? Is that useful? Is that possible? So that stands for strains, databases, and there is a big question about samples, so biobanking, so to speak. So it was interesting to hear this morning that in many clinical studies there is no sample collection for stools, for instance. So should we do that? Should we centralize the different samples in a unique biobank? Sorry, is that technically feasible? Is that financially feasible? Is that legally feasible? Question mark. And the last question was already addressed. So I think that's it for today.
Okay, thank you very much. So, any question that you would like to ask in the room? Yes? So, Vijay first and Christophe second.
I think your idea of strain collection is an extremely excellent and applicable, because I think to really amplify this program, we need isolated strains. So people who want to do mouse studies, and this doesn't limit anybody, and I think it really creates an access that's unprecedented.
You are talking about strain collection,
Yeah.
to be sure. Okay. So if I may, so how do you see that? Do you see that as a new collection, or as a meta, a network of
I think
people already?
you would definitely want to have more isolation, same strain isolations from individual people to see what's the variation. I'm sure there is variation, what that means at an individual strain level, and also, I think that's important to know, because is it truly true that we have 1.2 million strains, or is it that's an overestimation? I think there are a lot of limitations in I think the people who do informatics just show the data and walk away, with the people who are experimentalists have to then prove it, and they spend their whole life doing it. And so I think it's important to do that. Yeah.
Building on this, are you thinking about criteria or decision tree to decide how much?
Can you speak louder?
So building on this excellent idea of this strain collection, are you also thinking about criteria or decision tree to decide on how much time and effort will be spent on particular strains that are considered to be difficult to culture? Because a strain collection could be established by just introducing strains that are easy to culture, or you could refocus and look at those strains that are quite difficult to culture. And then it's a discussion of what is difficult to culture. It's only a matter of finding the right conditions.
Yeah. So that's a difficult question. If you are a scientist working in culturomics, your goal is to have as many strains as possible in your collection, just for the beauty of science. Okay. If we work in a framework like IMI, we should keep in mind that we should apply that to something concrete at the end of the day. And then the question becomes, what is important to know for strains? Why should I cultivate these strains and not that one? Honestly speaking, I don't know today. I have no clue. So the best way to start with is to cover as much as possible, and to try to see if there are some species or strains that are of interest for clinical applications. Honestly speaking, it would be, I don't know if you want to comment that, but it will be very difficult to say this strain, this species is completely unknown and we should look into it. This is completely fuzzy.
But could you think about feedback loops from some of the...
Yeah, sure. But those loops doesn't exist today. Yeah? You have, on one side, you have the cultureworks people working on culture techniques. On the other side, you have people doing clinical trials, and in between, you have some microbiologists that don't talk to each other that often. So we should close that loop for sure.
Okay, thanks. We have a question there first, and then we move to Dusko. Yeah.
Yes, hi, Frank from the DTU in Denmark. Could I ask, are you also considering including the data on, functionalities, and not just, here you have genes and genes and genes, but also you could have the genes that might be distinctly, related, but have exactly the same function. And it could actually be that in a microbiome you might have the one gene in one case constituting the same function as in the other case you have a completely different gene. And you'll be interpreting that as two different results. But in terms of a functionality, it's exactly the same.
Sure.
That could be for carbohydrate degrading enzymes, but of course also for antimicrobial resistance.
Yeah, I agree with what you're saying. I think functional aspects should be completely part of any project related to that. We have a small distortion at Biome because we're focused on identification of bugs. We don't speak that much about functions, but clearly in a microbiome setting for applications, we should consider functions and metagenomics for that, for sure. That's clear. And probably also proteomics and metabolomics.
Okay, thank you. Dusko?
You guys will think that I'm being paid for that. Actually, I'm not. You know, this notion that YJ referred to, bioinformaticians just throw things at experimentalists and they go away. I agree with that. But we have been looking literally at tens of thousands of microbiome profiles and have seen associations of species, communities with diseases across literally hundreds of projects, you know. And we can certainly, from the bioinformatics point of view, guide to samples where chances of catching these species or strains would be higher simply because we know that they are quite abundant in this sample or that, so the effort would be, you know, less. So I'm sure that we could think of this loop that you referred to, you know, where from in silico analysis one can go to samples, and if you had pipeline to isolate things which can be reasonably well isolated, I was quite impressed by work, you know, like from people from Trevor Lovely's lab, where it's reasonably simple, and then there is a Canadian methodology now which seems to be implementable. So things are kind of getting together for culturing. And before you answer, I just like to throw our attention, collective attention to the fact that there are really two aspects to that. One is to establish pipelines and things, you know, to do stuff. And the other is to maintain them over a long time. And my impression is that, you know, European Commission related institutions are not so strong in long-term establishment of things. So one should think about ways, you know, maybe IMI could help establish these pipelines and that sort of thing. But you need to integrate this durability, which probably goes through institutions or some other organizations.
Thank you, Dusko. For the first point, I think that's a great idea. If we imagine we could combine data sets coming from different academics and do some basic machine learning to try to identify correlations, and that could be, I think, quite easy to implement and probably quite interesting in results. So that could be a standard project, merging data, machine learning, and trying to identify some species of interest or some correlations or some causality maybe. Okay. Regarding point number 2, that's a good question for a company, I think, maintaining and supporting and documenting. And we'll be very glad to provide that to users, of course. This is why we are here, basically. So, because I think the academic people has to focus on science and research, and the company has to focus on product and services and quality and traceability. That's a natural split. So yes, why not?
Thank you. Any question? So perhaps I have one regarding the standardization you just mentioned. You mentioned different activities, like, for example, the international human standards, microbiome standards. So how do you see an IMI project building on those initiatives? Because there are many, and it's a
This is a question for IMI. I don't know. How do you set standardization? Honestly, I don't know. It's you have to go to agencies, ISO, for instance, in Europe, you have to talk to the FDA, for instance, or the, people like this. So there is some bridge to be built between the scientific community and the agency, for sure. And I facilitate that. I will be not the body to do that, but I think you could facilitate the interaction between scientists, companies, and the regulatory bodies. That's clear. How to do it, honestly speaking, I don't know. It's a long process.
Okay, thank you. So, any other question? I think we have a couple of minutes. So, left? No. Okay, thank you very much, Alain.
Welcome.